welcome to my channel. Let's see this problem pick from both sides from Interviewbit. So in this problem we have to choose B elements either from the left or from the right of the given array. So if X elements are from the left of the array, we have to choose B minus X elements from the right of the array. So let's try to code it out. Let's take a variable to maintain the maximum sum and initialize it to the minimum value. So that would be int minimum. And then we will try to include X elements from the left and B minus X elements from the right. So this I represents how many elements we are taking from the left. So if we are taking I elements from the left, we have to take B minus I elements from the right. So first of all, let's sum up the values until I index, that is int left sum is equal to 0. We traverse from the first index and it should be less than I. So each time we add this element to our left sum. Now since we have taken I elements from the left, we have to take B minus I elements from the right. So int right sum is equal to 0 for int a is equal to a dot size minus 1. J should be greater than a dot size minus 1 minus b minus x, that is b minus I and j minus minus. Again we have to just include it in our right sum plus equal to aj. Now we have the left sum and the right sum. We need to check it out if that is greater than our maximum sum. So maximum sum is equal to maximum of maximum sum and left sum plus right sum. So that's it. Let's try to return this maximum sum. Okay, this is the code and let's try to submit it. Okay, the test cases have passed. Okay, but our solution is failing on time. So what we can do over here is, instead of computing this left sum and the right sum each time, we can pre-compute these sums. So what we can do is, we can take another vector that stores the pre-sums, pre-computed sums, and it should have a length of a dot size. So the first element in this would be equal to the first element of our array, and then onwards it is just equal to the sum, previous sum plus the current value. So pre I is equal to pre I minus 1, that is the previous sum, and the current value, that is a of I. So we have the pre-computed sums. Now instead of using these two loops, we can easily calculate the left sum and the right sum from our pre-computed values. So left sum in this case, when we have to calculate the left sum for I values, it would be equal to p of I minus 1, because the indexing starts from 0. And an edge case would be that we have I is equal to 0, so I minus 1 would be minus 1. In that case, if I is 0, in that case left sum is equal to 0, else our left sum will be equal to d minus 1, and we have to initialize the left sum as well. Okay, now the right sum. We have to calculate the right sum for b minus I elements. So how can we calculate it? The edge case in this would be when I is equal to, so let's just write down the general case first. The right sum is equal to previous of, we have to calculate the sum for the last b minus I elements. So it would be the total sum which is given by pre a dot size minus 1, that is a complete sum, minus pre of a dot size minus 1 minus b minus I. Okay, so we have excluded the sum until the b minus I minus 1 value. So if we have to include one element from the right, it would be a dot size minus 1 minus 1. B minus I in that case would be 1. So it would be a minus a dot size minus 2. So a dot size minus 1 will be included and a dot size minus 2 would be excluded. Yes, so this should give us the right answer. Let's see if there is some edge case. The edge case is when we have no elements from the right. So it would be pre a dot size minus 1 and the right thing also would be 8. So right sum would be automatically equal to 0. Yes, so this should work. Let's see if our solution works. Okay, it's showing some error. Invalid initialization of non-constant. Okay, by mistake I put this ampersand. So let's try to submit it now. Yes, the solution got accepted, and thanks for watching, and please do subscribe. Thank you.